Hope all of you are doing well. In today's class, we will study about metals and non-metals. I hope all of you have got your books, pens and pencils, erasers, etc. ready, right? So now take out your book, science textbook, page number 45, and you have your chapter metals and non-metals. Now let's see how this chapter goes about. Metals and non-metals. So this chapter has been divided into 4 units. In the first unit, you will learn about metals and non-metals, the physical properties of them, and a few chemical properties of these metals and non-metals. And in the second session, you will learn about the chemical properties of metals and non-metals. In that, you will learn about the reactivity series, the reactions of metals with non-metals. And in the third, you will learn about ionic compounds and how they are formed and their properties. And in the fourth chapter, you will learn about metallurgy and corrosion and how to stop corrosion. And this session will deal about the physical properties and few chemical properties of metals and non-metals. Now, all of you know that metals or non-metals, basically they are elements. So, all the elements are classified as metals and non-metals. And how are they classified? Based on their properties. Based on their properties, the elements are classified as metals and non-metals. You can see the periodic table. There are so many elements over here, and these elements have been classified as either metals or non-metals depending on their properties. Now, let us see the first property of a metal. All metals have lustrous surface. Now, what do you mean by lustrous? A shiny surface. When you see a metal, you can see that it shines. So, this is called as the lustrous surface. Now, you can see here. So, these are the metals, and you can see the shiny surface over the metals. And all metals are malleable and ductile. Now, what do you mean by malleability and ductility? So, malleability is the property of the metal where it can be beaten into thin sheets. They are so thin that you can actually, you would have seen silver strips on sweets, right? So, these are metal strips, so they can be so thin. So, they can be beaten, metals can be beaten into very, very thin sheets, and this property is called as malleability. And ductility is another property of metal wherein the metals can be drawn into thin wires, very, very thin wires, and that property is called as ductility. Now, you can see here, this is a copper wire. So, it is a very thin copper wire. You have seen copper wires in electric wires, right? So, when you cut open that, you can see that above that there will be an insulation sheet. In that, you can see that it is so thin, the wire is very, very, very thin. So, that property is called as ductility. And this is aluminium foil. All of you have seen that. They wrap your parathas or your chapatis in that. So, it is very, very thin. So, this property of the metals which allows it to be drawn into thin sheets is called as malleability. Surprising factor is that gold metal has the maximum malleability. Imagine 1 gram of gold can be drawn into a wire of 2 km. Only 1 gram of gold can be drawn into a wire extending up to 2 kilometers. Imagine the ductility property of the gold. And now, another important feature of metal is that they are all solids at room temperature. All metals are solids at room temperature. You would have seen either the iron, the gold or the silver, whatever you have seen, they are all solids at room temperature. But, so you can see here the gold, it is the steel. But there is an exception. This is mercury. All of you would have seen mercury in your thermometers, not in the digital thermometer, but in the traditional thermometer, the clinical thermometer, you will see the mercury in the bulb. It is a liquid metal. Mercury is a liquid metal. This exists at room temperature in the liquid state. And generally, all metals are hard, but alkaline earth metals like lithium, sodium, potassium, they are very soft. They are so soft, they can be cut through a knife. You can cut it by a knife, but you can see here, you can cut the sodium through a knife. And metals are very good conductors of electricity. So now you can see a setup over here where you can prove that metals are good conductors of electricity. For that you require a battery, a bulb, a switch and a wire. So when you insert the sample to be tested in between the clips A and B, and if the bulb glows, that means that the metals are good conductors of electricity, or they conduct electricity. That is why we use metals in electric wires. And all metals generally have high melting and boiling points. So that is why they are used to make utensils. You have seen many utensils in your house, they are all made up of metals. That is because they have high melting and boiling points and they conduct heat very efficiently. Whereas there are certain metals like gallium and cesium, they have very low melting points. How low? If you keep them in your palm, they will melt. That means your body temperature is enough to melt gallium and cesium. They have very low melting points. But the other metals, they have high melting points and they have high boiling points also. And metals are very good conductors of heat. I told you already that is why we make use of that property for making cooking utensils. So now you can test by this experimental setup. So when you place anything to be tested, okay. So now if you heat a metal, if you actually heat the metal and if you put a wax at the end of that wire to be tested, then you can see if it really conducts heat, you can see that the wax at the other end should melt. If it melts, it is a good conductor of heat, otherwise it is not. I told you that is why we use it in utensils. Another property of metals is that they are sonorous, that means they make sound. So when you hit upon a metal with anything, you feel that sound. So generally all metals are sonorous. That is the property we use in the musical instrument. You could have seen a veena. Strings are made up of metals. So when you strike the strings, sound is produced. So a few properties of metals. Now coming to the non-metals. The non-metals do not have a lustrous surface. There are non-metals like diamond, graphite and iodine, which are non-metals, have a lustrous surface. Now you can see here, this is diamond, this is graphite and this is iodine. All of them, though they are non-metals, they have a shiny surface. You can see the shining surface of the diamond, graphite and iodine. All of these, though they are non-metals, they have a lustrous surface. And non-metals are generally solids, liquids or gases. They can be either in the solid state, the liquid state or the gaseous state. You can see sulphur, this is in solid state, and now bromine, this is in liquid state, and you have seen gases. And non-metals, compared to the metals, they have a very low melting and boiling points. And you know diamond, can you melt diamond? No, definitely not. Some non-metals are weak conductors of electricity and some are non-conductors. By using this apparatus, you can check the conductivity of a metal or a non-metal. Now this is graphite, and graphite is a good conductor of electricity and you can test it. These non-metals are not malleable, not ductile, and generally they are not sonorous. They do not produce sound upon hit upon. So these were the few physical properties of metals and non-metals. Now let us have an activity to check whether the metals and non-metals conduct electricity. Now let us observe the physical state of certain metals and non-metals. This is sulphur, this is charcoal powder, that is carbon, and this is graphite. These two are allotropic forms of carbon, which is a non-metal. So these are metals. This is silver and this is gold and this is brass and these are all steel. That means iron. Let us see the electrical conductivity of metals and non-metals. So for that you will require a battery connected to a bulb and the wires. Now if I connect, bulb is glowing, that means it is working. Now let us see here, iron is conducting electricity. This is also conducting electricity. This is also conducting electricity. This is also conducting electricity. And now this is silver. This is also conducting electricity. And this is gold. This is also conducting electricity. And now let's come to the non-metals. So this is sulfur. Does sulfur conduct electricity? No, you can see it is not conducting electricity. And charcoal, that is also not conducting electricity. And now let's see if graphite conducts electricity. See here, you can see graphite is conducting electricity, though it is a non-metal. So only graphite conducts electricity. Now since we learnt about the physical properties of metals and non-metals, now let's study few chemical properties of metals and non-metals, and this is one chemical property, metals reacting with oxygen. How do metals react with oxygen? All metals, when they react with oxygen, they form metallic oxides. Metallic oxides obtained by reaction of metals with oxygen are basic in nature. Metals like magnesium, copper and aluminium burn in oxygen and form their respective oxides. Magnesium reacting with oxygen, you can see here the magnesium is burning in oxygen and you can see that bright flame. Now we will see how magnesium exactly burns in oxygen.
In this experiment, we will demonstrate the oxidation process of magnesium. For this we need a 1-inch piece of magnesium ribbon or strip, a spirit lamp, a test tube holder, a lighter or matchstick to light the spirit lamp, and a watch glass. A cutter or a sandpaper is additionally required to scrape the tip of the magnesium ribbon or strip. This is an optional step. Light the spirit lamp using a lighter or a matchstick. Secure the magnesium ribbon or strip to a test tube holder. Hold the ribbon over the flame till it catches fire. Do not directly look at the flame as this can injure your eyes. Collect the ashes from the combustion in the watch glass.
You can see here, after the magnesium burns in oxygen, you saw that in the video, it is forming a white colored oxide which is magnesium oxide. This is the reaction that takes place when copper and aluminium react with oxygen. Copper reacts with oxygen to form copper oxide, which is a black colored oxide, whereas aluminium reacts with oxygen to form aluminium oxide, which is a white colored oxide. You have to remember the colors of the oxides. This is very important. When metals like sodium, potassium are exposed to air, they react very quickly and they form very basic alkaline oxides. They are very basic. The oxides of sodium and potassium are very alkaline. So now you can see here, these are the metals reacting or burning in oxygen. When they react with oxygen, they burn with different colors: lithium, strontium, sodium, copper and potassium. The potassium burns with a violet color, copper with a blue, sodium with the golden color, strontium red and lithium is pink in color. So when you dissolve the metallic oxide in water, they form bases. That is why they are called as basic oxides. So now we can see here, sodium reacting with oxygen is forming sodium oxide and potassium reacting with oxygen forms potassium oxide. When you dissolve these oxides in water, for example, potassium oxide, when it is dissolved in water, it forms potassium hydroxide, KOH, and sodium oxide, when it is dissolved in water, it forms NaOH, sodium hydroxide. Similarly, calcium oxide, when dissolved in water, forms calcium hydroxide. Magnesium oxide, when dissolved in water, forms magnesium hydroxide. Potassium hydroxide, sodium hydroxide, calcium hydroxide, all of them are strong bases. Most metal oxides do not dissolve in water. some of them they dissolve in water and it is called as alkali. They dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolve in water to form alkalis. You can see here sodium oxide in the solid state dissolves in water to form sodium hydroxide aqueous state. So, that is sodium hydroxide is an alkali, and potassium oxide dissolves in water to form potassium hydroxide, again that is in the aqueous state, it is an alkali. Now, if you are seeing something here, now what is this? Can you guess? It is aluminium. Do we know what is aluminium? Generally we have seen aluminium as the silver colored metal, but here you saw something called, which was very black in color, but that is actually aluminium. How did that become? So, this is by a process called as anodizing. Anodizing is a process of forming a thick oxide layer of aluminium. The aluminium develops a thin oxide layer whenever it is exposed to air. So, this aluminium oxide coat makes it resistant to further corrosion. So, to stop the corrosion, anodizing is performed. The resistance of the aluminium can be improved further by making the oxide layer more thicker. Oxygen gas that is evolved at the anode reacts with the aluminium to make a thicker protective oxide layer. During anodizing, a clean aluminium article is made the anode and is electrolysed with dilute sulphuric acid. The oxygen gas evolved at the anode reacts with aluminium to make a thicker protective oxide layer. This oxide layer can be dyed easily to give aluminium articles an attractive finish. Now, let us see how non-metals react with oxygen. Non-metals react with oxygen to form non-metallic oxides which are acidic in nature. Non-metallic oxides dissolve in water to form acids. Here you can see sulfur is reacting with oxygen to form sulfur dioxide, and this sulfur dioxide when dissolved in water forms the sulfurous acid. Now, let us know something about amphoteric oxide. Now, what are amphoteric oxides? Ampho, 2. So, these oxides they actually have dual nature. So, now you can see here there is aluminium oxide and zinc oxide. So, now when you see the reactions, aluminium oxide is reacting with hydrochloric acid to form aluminium chloride and water is released. Similarly, aluminium oxide reacts with sodium hydroxide to form a sodium aluminate and water is produced. Similarly, zinc oxide reacts with hydrochloric acid to form zinc chloride and water is produced. Zinc oxide also reacts with sodium hydroxide and it forms sodium zincate and water is released. Now, what is the importance of this? So, now as you can see, hydrochloric acid is an acid and sodium hydroxide is a base. Both aluminium oxide and zinc oxide are reacting with both acid and base, and the product formed is a salt and water. So, these oxides they have properties of both acids and bases. When an acid reacts with a base, it forms salt and water. Similarly, when a base reacts with an acid, it forms salt and water. But now here the aluminium oxide and zinc oxide are reacting both with acids and bases to form salts and water. That means they have dual nature. These oxides are called as amphoteric oxides. Certain metallic oxides they demonstrate properties of both acids and bases. They have both acidic and basic properties. Such metallic oxides react with both acids and bases to form salt and water, and they are called as amphoteric oxide. Example we already saw, it was aluminium oxide and zinc oxide. Now, let us see how metals react with water. Alkaline metals like sodium, potassium, lithium, calcium, they react with cold water very quickly and form their respective oxides, and in the process hydrogen gas is liberated. Now, this is sodium, it is reacting with water. Sodium when it reacts with water, it forms sodium hydroxide and hydrogen gas is evolved. Similarly, potassium when it reacts with water, it forms potassium hydroxide and hydrogen is evolved. These two are extremely exothermic reactions. That means much heat is produced in the process. And now you can see calcium reacting with water to form calcium hydroxide and hydrogen gas is evolved, but here the liberation of heat is less compared to the first two. You have to remember one important point here. Sodium and potassium, they react with air very quickly, not only with air but also with water very quickly, and they catch fire. That is why they are stored under kerosene. So, they are stored in kerosene, they can't be stored anywhere else where they can get into contact with air and water. That is why it is stored under kerosene, with which it does not react. Magnesium reacts with hot water and produces its hydroxide. You can see the reaction here. Magnesium reacts with water to form magnesium hydroxide and hydrogen gas is evolved. But this is with what water? Magnesium reacts with hot water and produces magnesium hydroxide. In the process, hydrogen gas is evolved. Now, you have to remember that magnesium and calcium, when they react with water, the heat that is liberated is not enough for the combustion of the hydrogen that is evolved. Hence, both these metals float on water, they do not catch fire. Unlike sodium and potassium, when they are reacting with water, they actually catch fire. But magnesium and calcium, though they react with water, the heat produced, the heat liberated in the process is not enough for the combustion of the hydrogen. So, these metals float on water when they are reacting. Now, you can see the two metals floating. See here, you can see the metals floating on the surface. Now, you can see different metals reacting with water. Magnesium reacting with water gives magnesium oxide, aluminium, aluminium oxide, iron, iron oxide, zinc oxide. In the process, in all the cases, hydrogen gas is liberated. Now, you can see this is an experimental setup wherein you can test the hydrogen gas. You can actually see that the hydrogen gas is evolved. You can collect the gas and you can test whether it is hydrogen gas. So, a metal sample is taken in the test tube and there is a glass wool that is soaked in water at the end of the test tube, which is heated. So, when you heat that glass wool, the water in that is converted into steam. So, when that passes through the metal sample, you can see the evolution of the hydrogen gas, and the hydrogen gas is collected in the test tube by the downward displacement of water. Now, let us see how magnesium reacts with water. Metals like aluminium, iron and zinc, they do not react either with cold or hot water, but they react with steam to form metal oxide and hydrogen gas is liberated. Metals react with dilute acids. Now, how do they react? We will see. Metals react with acids to give a salt and hydrogen gas will be liberated in the process. Whenever a metal reacts with a dilute acid, you get salt and hydrogen gas is evolved in the process. Magnesium, aluminium, zinc and iron, they react with dilute hydrochloric acid and form their respective chlorides. Now, you can see the reactions over here. Magnesium reacts with hydrochloric acid to form magnesium chloride, aluminium forms aluminium chloride, zinc forms zinc chloride, iron forms iron chloride and iron forms two chlorides. One is ferric chloride and another one is ferrous chloride. All the same, in the process, in all the reactions, hydrogen gas is liberated, or the metal displaces hydrogen from the acid. Now, let us see. Now, Now let's see how the metals react with acids. Now in today's class we learnt of few properties of metals and non-metals. Now let's see what we have already learned in today's class. We learnt about the physical properties of metals, the physical properties of non-metals, the reactions of metals with oxygen, reactions of metal with water, reaction of metals with hydrochloric acid. And now it's time for your homework. I'll give you a few questions for which you have to answer and show it to your teachers. The first question is, suppose you are given a hammer, a battery, a bulb and a wire with a switch. How will you separate given materials as metals and non-metals using these materials? And how will you use this test to differentiate the metals and non-metals? And another question, what are amphoteric oxides? Give 2 examples for amphoteric oxides. Now there is another question. There was a boy Pratyush, like you people. He took sulphur powder on a spatula and heated it. He collected the gas by inverting a test tube over it, as you can see in the diagram over there. Now your question is, what will be the action of the gas that was collected in the test tube on dry litmus paper, moist litmus paper? You have to think and answer, and you have to write a balanced chemical equation for the action that is taking place. I hope you will be able to do this. Another question, what will be the action of gas on the dry litmus paper and moist litmus paper? Write a balanced chemical equation for the action that is taking place there. Now another question, what is the nature of the oxides formed when the non-metals react with oxygen? I hope you remember that when you went through the lesson. Hope all of you will do this and you will show your teachers what you have learnt and what you have answered. All the question answers you will write in a book and show it to your teachers. In the next class we will learn about a few more properties of metals and non-metals. Till then, namaste.